All right, so this video is going back to the limits unit, and we're adding one more method that we have for evaluating a limit. And the reason that we waited until this unit to do it is because it uses a derivative as part of the process. So these notes are going to be on LHopitals Rule. All right, so LHopitals Rule says, suppose f and g are different functions and g of x does not equal 0 near a, you'll see in a minute, we're going to talk about the limit as something approaches a, except maybe at a, and the limit as x approaches f of x, as x approaches a, sorry, I was looking ahead. The limit as x approaches a of f of x equals 0, and the limit as x approaches a of g of x equals 0. So notice I'm not saying that g of x itself equals 0, I'm saying the limit is 0. Or the other form is the limit as x approaches a of f of x equals infinity, and the limit as x approaches a of g of x equals infinity. In that case, if these two things happen, then our conclusion is that the limit as x approaches a of f of x divided by g of x equals the limit as x approaches a of f prime of x divided by g prime of x. So that was a very mathematical definition. What LHopitals Rule basically says is if you're looking at the original limit problem and you get 0 on the top and 0 on the bottom, or you get infinity on the top and infinity on the bottom, then to find the limit, you don't rationalize, you don't fix a complex fraction, you don't factor, you don't expand, you don't use all those methods that we learned about in Unit 1. Instead of doing all of that, take the derivative of the top, take the derivative of the bottom, write it down as a new limit problem, and try direct substitution again. All right? So just to repeat that, if you can't find the limit using our old methods, we're not going to be doing that. We're going to say the derivative of, or not the derivative, the limit of the top is 0, the limit of the bottom is 0, or the limit of the top is infinity, the limit of the bottom is infinity. Then instead of using those methods we used before, we're just going to take the derivative of the top, the derivative of the bottom, write a new problem, and try it again. All right? So we're going to go ahead and practice this a couple times. So for example, all of these examples have the instructions to evaluate the limit. Right, so example number 1 says the limit as x approaches infinity of x squared minus 1 divided by 2x squared plus 1. And if you guys remember, we kind of talked about this. We said, I talked about n to the n FEPL. So when we look at this, I already know what the limit of this is. We learned about this when we were talking about horizontal asymptotes. I can see that I have x squared over x squared, and that those infinities are going to be the same size. And so that means that the infinities would cancel out and I would get 1 over 2. So I know that this limit is 1/2. And I can use the ideas from horizontal asymptotes, I can use the ideas from n to the n FEPL, and figure out what my answer is for this problem. However, now I need to go ahead and say I actually know the reasoning behind why that answer is the way that it is, and the reason is LHopitals. And so from now on, we're going to use LHopitals to prove those limits instead of using some of those other methods that were kind of like cheating. So here, when I look at this one, I'm going to break it down. I can see that if I plug infinity in, I'll get infinity on the top. If I plug infinity in, I'll get infinity on the bottom. So I'm going to write the limit as x approaches infinity of x squared minus 1 equals infinity, and the limit as x approaches infinity of 2x squared plus 1 equals infinity. And so my conclusion from that is now I'm going to use LHopitals. Okay, so I'm going to rewrite the problem. The limit as x approaches infinity of 2x divided by, so 2x minus 0 divided by 4x plus 0. I can see that if I was to plug infinity on the top, I'd get infinity. If I plugged infinity on the bottom, I would also get infinity. So I'm going to show this work again. It used to be that you could kind of look at this and say equals infinity over infinity. So I'm going to use LHopitals. And what the teachers found out this summer at the AP teachers training was that on the AP exam last year, they actually marked every single kid who did that down. And that's like something literally everybody writes it that way. Nobody writes it like this. But now if you don't write it like this, they're going to mark you down. So that's why I remade my video and I'm teaching you guys the right way so you can earn all the points for these. Because these are nice problems to earn points on since they're not too difficult. All right, so we're using LHopitals again. I'm going to rewrite it again. The derivative of 2x is 2. The derivative of 4x is 4. And the limit of 2 over 4 is just 1/2. So I knew the answer all along, but mathematically this is the rule that we were allowed to use to show it. So I'm going to go ahead and show you. These are my notes from last year. This is how simple we used to be able to write it. We'd say like infinity over infinity, I'm using LHopitals. Infinity over infinity, I'm using LHopitals. And then we found out this summer that this is technically not the answer. And when you say equals, you're saying it's the answer. And that's why they were marking it down. And then here, they're not letting you abbreviate that because there are other names in math that start with L. And they wanted to make sure students know it's LHopitals. And that the definition says the top goes to infinity, the bottom goes to infinity. So now you have to write it this way to get points. You can't even write infinity over infinity in the margin of your paper. They will mark it down for that as well. So just something to watch out for. Don't shortcut this. All right, example 2. This one says the limit as x approaches 1 of ln x divided by x minus 1. And if you look at this problem, if you were to plug in 1, ln of 1 is 0. And 1 minus 1 is also 0. So that means I'm going to use LHopitals. And I'm going to go ahead and write my work off to the side. So the limit as x approaches 1 of ln x equals 0. The limit as x approaches 1 of x minus 1 also equals 0. And all together, that tells you to use LHopitals. Okay, so we're going to go ahead and take the derivative of the top and take the derivative of the bottom. So the derivative of ln x is 1 over x. The derivative of x minus 1 is just 1. And now I'm going to think about that direct substitution again, and I can actually do the direct substitution. So I would have 1 over 1 divided by 1, and that just equals 1. And so that is our limit for the second example. All right, let's go ahead and do a third example. We're going to do the limit as x goes to infinity of e to the x over x squared. This is a really great n to the n Feppel problem. So I'm going to go ahead and write this down. F-E-P-L-L. So the top is exponential. The bottom is polynomial. The top is going to win. So that means that my answer is either a positive infinity or a negative infinity. I can see that I'm plugging in a positive infinity. E to the positive infinity is just positive infinity. Positive infinity squared is going to be positive. So I already know that this final answer is infinity, that it's unbound, it doesn't exist. But I can use LHopitals to actually prove that. So if I look at the top, I already said that if I plug infinity in on the top, I'm going to get infinity. And on the bottom, if I plug in infinity, I'm going to get infinity. And so my conclusion is to use LHopitals. And so I'm going to rewrite the problem. The derivative of e to the x is e to the x. The derivative of x squared is 2x. And again, I can see infinity on the top. If I plug in infinity, I get infinity on the bottom. So I'm going to write all this stuff again. And again, we are going to use LHopitals. And I'm going to write a new problem. E to the x over 2. And this is where if I was to plug infinity on top, e to the infinity is technically infinity. And infinity divided by 2 is still just infinity. So it doesn't exist. It is unbound. Okay? And we make sure that I had you guys plug in infinities as you were learning how to work with them, but technically we are never, never, never allowed to write e to the infinity divided by 2. That is mathematically incorrect. You can't actually plug in infinity. It's not a number. You can only find the limit of infinity. So this is actually mathematically how we show that we are plugging in infinity. We can't actually do it. So I'm going to erase that. That's not correct. Okay. Problem number 4. Actually, I think I'll leave this one for class. So that's it for the video. The important thing is to remember that you can only use LHopitals if it's 0 and 0 and infinity and infinity. They have to match. You can't have 0 for the top, infinity for the bottom. You can't have that. You can't have 1 for the top, infinity for the bottom. You have to have 0 and 0 or infinity and infinity for it to work. So just be careful to watch for that. And other than that, it's kind of a nice tool to be able to use when you're solving a limit.